you submitted. I received the whole proposal from the file team. Before we start, next week Tuesday, is it possible to have a lecture 1 hour earlier? So, which means the 12 to 2:30. Any problem, anyone? 12 to 2:30. Okay, so next week Tuesday we will have the lecture. Do you have any problem? Yeah, Yang-Wei?
No problem. Yes, sir.
Yeah, 12 to 2:30. Only for the next week Tuesday. And this week we will have another lab using the administrator. So do not remove your cursor yet. So you will use one more time. Also, your team can use that cursor also, or you can set up if you want the new one. Also, if you want to use the room after office hour, let me know. I already informed the two of the students. But if you want to use the room after office hour, email with your name and the ID. So, first, team number 1 is Ali and Saul, right?
Yes.
So, this is a firm. The project is an event. This is the system, something like that. Do you explain quickly about your project?
Yes, our project is meant for event planners. One thing that we saw, there are many festivals and activities that are being done outdoor during the year. There is like in Texas, there's Alamo Festival and other festivals. So we intend to choose to collect data for around 40, 50 different cities. And we collect the data for the past 60 years, 63 years in specific, to decide how many good days in average for each month for the past 63 days, 63 days, to decide whether, like for example, in January in general for Boston, an average for the last 63 days, we see that there are, for example, 4 good days only in January. So it's not a good idea to select if you want to host your event in September and January. It's not a good idea to choose Boston. And we have selected 4 factors to decide whether a day is a good day or not, which are temperature, overcast, humidity, and wind speed. So in general, I think in conclusion, we can come up with a figure that shows in January, we see that, for example, the best city that has very good day, that has the most good days in January would be, for example, let's say San Francisco could have 20 days in January, then Boston, then in February, and so on. So I think that's a good idea because now the people who are going to host a festival or an outdoor event, they don't have to care about which month they decide. Which month they just have to select the most city the best city, the best suitable city for them.
Okay, so you are going to use the weather data to decide if the event is a good for day or not. I see.
As an average, yeah. For example, the last figure we're going to show is like a figure that shows in January. For example, Boston, San Francisco has the most good days.
This is not the only problem your team, but in general, it's the same problem because I think not a big deal, but because this is the first time to use the data system, especially for the Hadoop. It's a little bit different from the proposal that you have used in other project or other class. The first one is a data set. Okay. For the data set, if you know you have the very nice idea or the very wonderful problem definition, if you cannot have the real data set or sample data set, or at least you should be able to make the sample data set by yourself. Okay? So it's a synthesized data set. If you cannot get such a data set, no way to implement the system. So you need to specify how to get such a data set from the data source and the format where you can get the data set or how you can get it. Sometimes you can download the existing benchmarking data set from government website or the commercial website, or you can build your own program to collect such a data set using APIs such as the social media website, the Facebook, Twitter, or Flickr. They have their own API. So using such an API, you can collect such a data set. Then, how much big? How big the data set is? Okay. So for your implementation, so we are going to have the 1 megabyte data set. That doesn't make sense in this reasonable size in your data set. For example, in our configuration of the header system, we use 64 megabyte the block size, which means at least to have the multiple blocks, your data set should be bigger than that. So I think, in my opinion, it should be around the gigabyte level. Okay, I don't expect a terabyte sample data set, okay, but at least the gigabyte size the data set you should be able to collect. So then what's the format? What information in the raw data set? In the original data set, it has the temperature. Temperature is the what kind of format, okay? And it's whether this is separated by the line or comma, or the most of the team needs such information. Okay, so it's a good idea to show the sample part of the header, 5 or 6 lines of such a data set you collect. Okay, so that is very, very important. Also, sometimes we will discuss about how to transfer data set from source to the header system. So you can use such a ETL procedure, extract the transfer and upload the data that we are going to discuss today. Okay? You can also think about such a thing, but this is not mandatory, so this is optional. The second thing is definitely problem definition. If you do not have any problem, there's nothing you can implement, even though you have very nice. Yes, this is our objective or the problem that we are going to. For example, in this case, we are going to find the frequency of the good day or bad day by the month, by city, something like that. However, if that is too simple, like a word count level, that doesn't. It's not very attractive. Okay, so you need to think about first. You can start from the. For example, if you just count the number of the good day, okay, the clear day, I don't think so. But if you count such a thing by city or by region or by something, then it will be a little bit different. Also, if you can consider other lookup table, that's totally different from the word count. Okay, in source data set, it has only the just shows the temperature. Instead of the temperature, you are going to replace such a temperature by something additional information. It's kind of the lookup table. It's a small table. In terms of the relational database model, it can be considered as a drawing operation. Okay, not directly in the drawing in here, but it's a more complicated procedure. So you need to define clearly problem definition as you are doing in any project. Without definition of such a problem, there's nothing. If you cannot find any problem, you don't have to do that because there is no problem. Okay? So that is another thing that you need to do. And in this, the classroom project, because we are using the header system, you need to design at least the mapper and use MI okay, process in terms of data flow. So because as I mentioned many times, the data types of the MapReduce program is the first thing that you need to solve, right? So what is the input data and how to extract the information that you want, then how to emit the information that you want. Then that is the intermediate output of the mapper. Then what is the reducer? Then in mapper and reducer, how to handle such a data. Not only one set of a pair of the MapReduce, sometimes you need to have the many the MapReduce program. Sometimes, depending on the output of the reducer, it can be yes or no or the condition case. Okay? So you can start from the simple MapReduce program just like the word count, but you can extend based on what problem definition. Okay? So that is the reason problem definition is very important. Not very difficult, but not too simple one. So you should be able to manage such a thing next to 2 or 3 weeks. That is another one. Also, you can consider other components, combiner or partitioner, and so on. Okay? Yeah. And pretty much that is the missing part from the most of the team. In this project, I think you need to specify more in details of the problem definition. Okay, also consider how to, in terms of data flow, how to design MapReduce, mapper, and reducer.
Yes, Professor, in the last paragraph, I explained a little bit about.
Yeah, too little.
Yeah.
I already commented on your canvas, so you can check it. Okay, so it's the team number 1. You can take it. So, core data record analytic using the heading cluster by team 2. So, Aram side and Tafikar.
Yes, sir.
Either of you, can you explain very quickly about your project?
The main concept of this technology is like all detail record that came from the telecommunication network switches. We call it mediation system to calculate the each call transaction data. We have data set here.
Is the sample data set?
Exactly.
Okay.
There is a sample data set, and this sample data set can define the SIM number and can define the phone number as well as the call start time as well as duration of the call. So for our system, we will handle considerable amount of CDR data that is in text format, also including ASCII format. And we will port this data in HDFS, and we will try to come up with some map and reduce function. So in this map function, we will parse these lines and take out the phone number, SIM number, and duration. And for one given input of phone number, we will calculate how much duration it has already called, so that we come to know for a single number what is the call duration. This is the phase 1 because we want to finish this for a big set of data. For the time being, we have only 10 megabytes of data. We will increase the data set now so that we can run with our Hadoop cluster. We can many things can be done because once I parse this data and we can do map and reduce for this data, we can come up with some other solution as well. How many destination the number has called to? We can also find that. But yes.
Okay. So do you already collect the data set?
Yes, Professor.
So you mentioned about your data set is around 100 megabytes. So can
We
you
have-
use the more bigger data set?
Currently, we have 10 megabyte of data set. We will make it 100 because.
By the way, where do you get such a data set?
Yes, Professor, that's a good question because I'm from Bangladesh and I have worked with IP telephony for a long time, last 5 years, as well as I have contracted. For this reason, I have connection with operator companies in Bangladesh as well.
Okay. Okay.
So we have a close contact with that company, Bangladesh, and it has got 30 million subscribers nationwide.
So you are the guy who called me.
They are providing data system, and they are also implementing the Hadoop cluster as their backup system. They are not in the production system right now. They are in the testing system, so they are taking help from us as well. Our application might help them to get it to the production level.
Okay. Okay, that's good. So I think the team number 2, team 2 is one of the best proposal out of the 5. And also the only thing I can mention to you is based on the problem definition. So in mapper and reducer, okay? So anyway, not only define the input and output format of the data, intermediate data and output data, but also you need to implement something inside mapper and reducer, your own algorithm. Okay? Based on what? Business logic and business intelligence. That's more important. In word count, what is such an algorithm? Count. Okay? In team 1, what is the algorithm? It's a count by something, right? Count by something. You add just 5 group by. And just like that. So after you design such a mapper and reducer design, the next one is algorithm. Sometimes you can use a very complicated algorithm. Sometimes you can use the data mining technique. I think I suggest you whether you can implement for example decision trees, something like that. Not just the frequency. After you figuring out such a frequency, it's one of the pattern that I gave you. You see the PDF file that I gave you. It's already uploaded. There are 6 or 7 patterns of MapReduce program. One of them is the summarization. It's a frequency. But there are more the patterns of the MapReduce programming. You need to think about such a thing based on problem definition and MapReduce design. Then eventually you need to implement the design. This is the most important one. Eventually. So even though you know how to use the SQL, like a select from where, that doesn't mean that you can implement the entire database system. Okay, you should understand such a business logic and business intelligence. Okay, that's much more important in the market. Okay, so how to implement? I don't expect you in this small classroom project you implement very complicated algorithm, but you should be able to implement your own, sometimes the existing algorithm that's running on the traditional system, you can port to the big data system based on the MapReduce. As I mentioned many times, not all the algorithms can be converted to the MapReduce programming. Simply associative and commutative. The algorithm can be running, and what if they are not commutative or associative? There's a way, even though you lose some consistency. Okay? For example, the frequency of the clear day is actually 100, the 1 million, for example. And is it different from the 1 million plus 1? It's not much different. Okay? As long as we can get the trend. Okay? So you need to think about such a thing. At that time, such an algorithm problem definition is good for big data. What is this? Why don't you go back to the very first class? So for example, flu trend in the food. So instead of investing from the CDC is a clinical disease center. Okay. So in US, instead of they investigate the entire continental, they can just count by state what is how often the flu is searched. Then they can find the northeast, course is the outbreak area for flu. That is the benefit of the big data. Okay? Then you can implement such a thing based on the summarization or frequency. Similarly, when you define such a problem or implement such a thing, think about how to use such a benefit of the big data in your data set. Very nice. So this is a team 2. This is a team 3. Right? Barakuma, Anil, and Nancy. Right?
So we are working on the massive multiplayer online role-playing game World of Warcraft. We're getting data sets from World of Warcraft team. So the game has been developed by Blizzard Entertainment Company.
So, is this different from this one? Which company? So first, why don't you explain about your project very quickly?
So basically, this is from a game World of Warcraft, which is developed by Blizzard Entertainment Company. So the game is a
What is the name of that company?
Blizzard.
Blizzard. Okay.
So the game is an online.
It's the StarCraft, right?
Kind of, that's a different game developed by them.
Is it different? I'm not good.
So everyone will be having, every individual player who plays this game will be having a profile. So they have different characters to play the game. So based on region, they have private servers as well as public national server. If you take a private server where they have millions of people playing anytime on the server, they've been doing different tasks and missions in the game. So for example, if I've been given a mission to attend Professor Lee's class, I have had some problems in either doing the task or going on the way to achieve this task. So the individual, they report these unfinished, incomplete tasks to the Blizzard company. Based on these analytics, the data which they get from the individual players, the game developer, they start analyzing, this task has some problem, so we need to work on it. And this, based on this data, they start working on the task. Either they improve animation or they improve how many users play the specific game or how much revenue are they going to generate from the user. These are the expected outputs of the project there.
So I think according to my suggestion, you can revise.
Yes.
You don't have to revise and submit it again, but for your project, for your self, you need to think about how. After you set up, you can already get the permission to get the data set. How big is that?
We are working to make 1 terabyte of data.
1 terabyte is too big. Yeah, so around the gigabyte or several gigabyte. So for your project, but for testing, you can use the small size of data definitely. And you are going to use the user profile information, right? So for that, so you clearly define, but it's just the title, so you need to specify for that. I don't ask you to implement everything. You can start from the one of that fit the easy and fit to your objective, then consider. So my suggestion. Okay. And this is the team 3. Team number 4. Okay, so the Mount and Yang, and you can explain the.
Yeah, and for our proposal, we download the data from the National Ocean and Atmosphere Administration. That is about the weather data, and we are searching about the precipitation. And because the precipitation is public data and easy to download, and we want to search about the precipitation and to evaluate which parts is good for farm, because the precipitation can help us to aggregate the farm. So this is probably what we define. And for the data set, it's around 20 gigabytes, and that is the text file, and it includes the 20,000 stations all over the world. Maybe we just use some stations in the United States, and it will reduce the size maybe. And it includes every day's maximum temperature, minimum temperature, precipitation, and the snowfall and the snow dip. So this information can help us to evaluate, and we get the other formula from the website. They can't use every time the snowing, like the precipitation level of the how much the drops the height, and use that to calculate whether this is a good effect or not good. So we can use this to calculate.
One of the popular applications based on the Hadoop system or the data system is kind of recommendation system. It's not only the recommending the movie in Netflix, even though that starts from the movie industry, but it can be used in any industry, even this kind of things. With recommending which curve or the money is good for this one, or based on the precipitation information, something like that. So at that time, you need to consider kind of the probability, statistical approach. Based on means conditional. So conditional, so you have the regional information using some the geographic or the weather information, and also you have just the bunch of data, like the temperature and the precipitation, and whatever. Then you suggest 70% or 80% good for this one, based on the output of such a farming or whatever. So you can think about such a recommendation system, but here the problem is how to figure out whether this is good enough or not. So you need to think about such an algorithm or how to implement in your MapReduce program. Okay. Last thing is the team 4 and 5 are using the same data set. The NOAA, they provide the public data set. So can you explain a little bit about the project?
So our project is going also in weather and purpose of this one to show the lowest and the highest temperature during the month since 1990 up to 2014. So each month we're going to find which is the highest and lowest according to zip code. So
This is the original data.
this is the original data. So this is 1996 July. So we're going to take this data and count how many days, then we're going to take the average of that, then we're going to find which is the highest average in that month during by the zip code. So our data is almost about maybe 10 gig because each file around 60 meg each month. So we have 12 months a year, then we have 10 years, so gross 10 gig. Then we're going to find, at the end of that, we're going to find this is the final output. We're going to have the partition, we divide each file by the zip code. So example, the first zip code is 5.4, then we're going to have July 1996, the highest in July like that, and the lowest is going to be then go on. So we're going to, by the end, we're going to find, we try to eliminate this insertion by we're going to do the Connecticut zip codes because we know United States many zip codes, so then they're going to take two them. So I think we try to straighten 21 so far. Then if we have time, maybe we're going to go run for the whole zip code.
Yeah. So I think overall it's a nice proposal, but it's a little bit simple. The problem, highest and lowest by something, is just like the thing number 1. So after you implement this one, think about the more complicated the problem. Okay, that you are going to use this kind of data set for the specific problem. Also, so for all the team, it's also possible you can focus on the problem definition, application problem, But also you can focus on the how to, you can still use this one, but for example, if you are using combiner, so my combiner is secured, how to balance. So you can focus on the performance, overall performance of your system. You cannot modify the source code of the headed system, but by adding some module or algorithm in terms of software, is there any other way to increase the performance, like the speed or accuracy? So you can focus on that part after you finish such a thing. Yes.
So actually, we decided to cover an prediction software.
Yes,
We told
that's
this
another.
one,
Yes.
But once we read about the prediction tools, so it's gonna be take too long.
Yes.
We're gonna have time.
It's not easy.
So yeah, not easy. So that's why maybe we're gonna take this one as the first phase, then
So,
the second phase we're
For
gonna.
example, when you predict such a weather condition or the similar thing, so it will be based on the experience. Experience means it's a history data. So in other words, if you can find something clue or correlation of such information. For example, if we had, you realize expertise already know based on their experience, long time experience, if we have this little bit windy from northwest with more than 40% of the cloud, it will be rain, 80% rain. Even though they never process the data, they already meteorologists, some of the expertise in the meteorologists, they, based on their experience, know that. The problem is whether you can find such a correlation of data that related to the weather forecast or some prediction, whether you can implement such a thing. Okay? One of the naive way, easiest way is conditional probability, like the naivation. Okay? Or in addition to that naivation, there are many others. So you already learned what is a conditional probability in your high school math or college math. So like not just the occurrence of the A, but based on, in case of B, what is the probability of the A? For example, the C, A, B, A. So in case of the B, what is the probability of the A, something like that. So you can think about such a condition of probability, but it's your responsibility if you want to implement such a thing.
But Professor, like, to implement the data mining, like decision tree, I think this decision tree is just going to give you, it's not more accurate, it's just going to give you faster response.
So
because it doesn't check all the decisions.
In simply in short, the decision tree, you try to find, it's the same idea. Whether you can find the relationship between the attributes.
The factors.
Yes, factor, in other words, factor. Okay, you need to find such a relationship between or among such an attribute or factor. It's called the attribute, the feature or the attribute in terms of data mining. So that, using if the temperature is higher than 75 and the humidity is less than 30, it's going to be clear data, so 80%.
And the most attribute has information gain.
So it's up to you to implement such a thing in your project. It will be nice. So overall, it's good proposal based on by considering the command that we discussed today. So why don't you revise your idea, and you don't have to resubmit it, but moving forward for the implementation. So you can use either the cluster that you built last week, or if you want, you can build your cluster by yourself. Okay? Then start from the designing your map videos, and this is a requirement. Using map videos programming. Sometimes you can use the other interface that we are going to learn today or the next week. For example, Hive is a sequence type, the component ecosystem. If you run the select from where, is automatically converted into the map reduce program. I'm not going to accept such an implementation, even though you know how to do that. For your practice, I'm going to ask you only the map. This is the only requirement in your project for your better skill of using the map reduce. Okay, this is straightforward. Without understanding map reduce programming, it's automatically convert. Then, if you do not know, if you do not implement such a low level, not low level, but anyway, the map reduce programming, you never understand such a thing. So this is the only requirement. But for data transfer, for example, all of the team manually transfer the data, manually download or collect such a data, then upload to your HDFS. But there are ways to automatically transfer from data source to Hadoop system that we are going to discuss today. So you can use such a ETL data transfer for your project. Then the final, the output of your project is demonstration and your source code as well as the writing up. So if you pursue the submitting your work, so if you believe and I agree, so your output is the new idea and it's worthwhile to submit the journal or conference publication, it should be the writing one, okay? The conference summary writing. Otherwise, at least the writing up should be the poster side. Probably you see the poster in the conference, the technology building. So it will be you submitted to the upcoming event that we are going to have. So your output is, if you either paper or the poster. The poster requirement is exactly the same as the ASA conference, the poster session. If you do not have such information, why don't you find the website, the last spring, the website, then it will show the 2 feet by 3 feet and the PPT file. Then I'm going to use that one to for the upcoming event. Okay. Any objection? So, especially for PhD students, I strongly suggest both the writing up and the PPT file. Okay. Then we are not going to have the final exam so far. But if you all the team messed up your project, you definitely need to have the final exam for your grade.
Listen, do we have to submit the paper by 6th July?
By the end of semester, I don't think I believe that some of the team has a good idea and good starting, but not enough time to finish it. At the time, you can prepare the poster only. Then you can keep working for that. Okay? So at least the poster should be the final output, one of the final output. So demonstration, source code, and source code should definitely include the sample data set, okay, as well as the writing up. Writing up can be either the poster or the paper. So today, we are going to have scoop and from. What does it mean, scoop? Actually, it's not dictionary word, right? So SQL plus the Hadoop, but it looks like something like the scoop, right? Scoop. Right? So it's a similar idea. So we try to scoop the data from the original data source to feed one Hadoop system. And the from, what is the from? Have you ever heard about this word? Yes, this is a dictionary word. And also, probably you know this one. I loved this when I was a kid. So let's is it connected? Any? I think it's connected.
It's not to the slide.
Right. This one. Actually, this is a front line. If you go to the amusement park, or this is also, if you go to Disneyland, or this is a Dragon Park, this is a plumb line. Okay? Using what? The rope. Okay? So if you go to the Maine, upstate, the Maine or the New Hampshire, there is the sightseeing for the flume. So long time, so several decades ago, to move the rope or tree after cut down, they use the stream, okay? And they use the way of the stream to move the big rope or big tree. That is called a flume. So which means it's kind of stream of the rope or tree, stream of air. So after, so they named it after this one. I don't know why it's not selected. That's a mistake. You can see this is actually the low, long time ago. Low. Have you ever tried this? Yes, this is a flume line. So, and also after summer session, why don't you go to New Hampshire or Maine? There are several places for flume. So last year I went to the, I think it's in New Hampshire. Yes, this one. Actually, the stream was used to move, transfer the big load at that time. So this is called the flume. So using this idea, we are going to transfer the data. Actually, why we need such a big data system? Actually, it started from the low data. Okay? So each system, each server, each computer creates a huge amount of the low data, whether or not you realize. Why don't you think about your laptop, Windows-based operating system? So even Windows create a bunch of event data. So sometimes I get tired to get the messages, so I disable the service. But if you enable the service, it create a bunch of the system log, application log, or sometimes it's a critical error, sometimes just for your information. So is there any way to utilize such a log information? Yes. So sometimes, for example, the network. So in terms of hacker would like to access the system, they do not know the authorization information, username and password. They keep trying. Also, sometimes a hacker would like to shut down the system by sending a bunch of data to the server. It's called the DDoS, right? So how do we recognize whether this is the authorized packet or whether this is the hacker, packet from the hacker. So there are the pattern. For example, usually the packet from the hacker, they have the period. The packet like the 0.001, so every 0.001 they send the same size of packet, something like that. But in general, the packet, there's no pattern, something like that. So can we analyze such a pattern? At the time we need a big data system. However, the server are distributed. So here, there. For each and every enterprise level, the IT environment, each server or each site has the more than 100 servers. But you have the one big header system. So we need to collect such a low data from each data source. How can you do it? So you transfer using the FTP and do manually. So it's a tedious job. Also, even though you make the automated system to move this data, but you need to upload to the header system. At the time you need to run the header FS and put such a data and log data. Each log data has different. Also, what about the different types of data sources? Sometimes this is just a log data under TMP log, whatever. But this is from
Windows.
the IDBs. Okay? This is not the log data, this is the log information. Yes, suppose that this is the log information, log data, but this is the table, relational database table. Okay? And transition. And this one is different data source. Can we get such a data from heterogeneous data sources? To address that problem, there's a part of the ecosystem which is called scoop and flow. Scoop is, as you can imagine, is from SQL style, which means it's a relational model. From the relational model, you can get such a data. So, and on the other hand, the flow is for just low plain text data sources. So you can get the data. So today we are going to learn how to use such a flow and flow. If I ask you to implement, you have already run the relational database model. Okay? You have the relational database, a table that is a transaction table. So in online banking system, we have the transaction table is still increasing very, very rapidly. Okay? Then we try to get such a transaction log into the Hadoop system. How can you implement? For S without scoop. How can you do that? Any idea? How? So I asked you to implement the project. Okay? So that can transfer data from relational database and upload such a data into Hadoop HDFS as a file. How can you do it?
You have to write many algorithms.
So you need a map-reduce programming, right? In the map-reduce programming, you can actually create a file, right?
Change the type.
So you can open the file and
It's not the
write
data.
the data. It can be map-only program, right? You can just write the data. Then how can you get such a data and transfer and do it? Using this is the big example what? Java, right? In Java, how can you access the relational database? JDBC. Java database. So using JDBC, you can access them. It's a very simple. So you already did in your advanced database design class, right? So you can just just include the JDBC class, okay? Yeah. Then call the connect and give the connected string, username and password, and you can execute any SQL language in your JDBC Java program. You can just include this Java program in your Matrix program. That's it. It is good. It's not very complicated. So even you can implement by yourself. So this is the scoop program. So let's see the register scoop in detail. So in case such a database is the structured database format, okay? So such as the RDBMS or the data warehousing or other SQL. This is the first time to see the NoSQL. We will discuss it at the end of today's class. What is the NoSQL? Very briefly about it. And if you are interested in such a NoSQL database, so I'd like to offer the one class in 4th semester. So this is nothing but the map reduced programming. Probably, I guess it's a map only programming because it's just to create a file and insert the data. Then with the help of the JDBC, so that is the scope. So from the MySQL or the Oracle, as long as the JDBC support the Java database connection for specific database, you can implement such a thing. Then